Hi, I'm Pat Kelly. Okay, in this problem, we're asked to find the general solution to this differential equation, and then use a graphing utility to graph the three different particular solutions that would correspond to the values of c that they gave us, c equals 1, 2, and 4. So we'll begin by trying to find that general solution for this differential equation. In this section, we were learning about the separation of variables method, so I'm going to stay consistent with that. My thought then is to try to get the x's on one side and the y's on the other. That's just one quick step this time. The dx in the denominator I'll put over the other side, and we'll get dy equals x cubed dx. And then the next step in that separation of variables method is to integrate each side. So I'll integrate left-hand side, integrate the right-hand side. Now I'm going to do the integration on each of those, and on the left, the integral of dy is just y. And the integral of x cubed is the power rule, x to the fourth over 4, plus that constant of integration, which is what's making that the general solution for this differential equation and not a particular solution. So that's the answer we want for the first half of the problem. And the second half of the problem is now going to give us the specific values of c, and we're going to graph those with a graphing utility. So the first one they give us is c equals 1. I'm just going to go to my general solution and put in that value of 1 for c. So this becomes the function that I would now like to take a look at if I could graph it. So I'm going to go to a graphing utility and bring up my y equals, and I'm just entering x to the fourth divided by 4 plus 1. And on my calculator, that's y sub 1 on my calculator. Makes sense? I'll just hit graph, and I'm looking at something that's kind of like a parabola, but it's x to the fourth, so not quite. We're going to go on to the others, but as we go in to the others, I really like to take a look at them together and see how they compare. So one quick thing I'm going to ask you to do is change your window settings, just so we can have a good perspective on the final result of each of the three being drawn. So for my window, I'm at a -8 on x min, a +8 for x max, a -8 for y min, and a +8 for y max. Okay. Now we're going to go on to the second value of c that they give us, c equals 2. I'm going to go back to my general solution and put that value of 2 in for c, which just gives me the y equals x to the fourth over 4 plus 2. They're asking us to also graph that on the graphing utility. So I'm going to instruct you maybe to put this as y sub 2. So we're going to go to the graphing utility now and hit y equals. But in the second line for y sub 2, let's enter x raised to the fourth divided by 4 plus 2. If you want to go ahead and hit graph, you'll see how the first two of these particular solutions compare to each other. Both same shape. One is just a vertical shift from the other. All right, let's wrap up the problem with the third value of c they give us, c equals 4. Back to my general solution, y equals x to the fourth divided by 4. But in place of the c, I'm going to put in my 4. And this becomes the third particular solution I'd like to take a look at. And I'm going to encourage you again to add a subscript there when I go to the graphing utility. Let's enter this one under y sub 3. So to the graphing utility, I'll hit y equals, and then down on that third line, let's enter x raised to the fourth divided by 4 plus 4. And then I can graph. It might take a second, but you'll see all three of those particular solutions all at the same time. And all you see in terms of the difference between them is just a vertical shift. So your general solution looks the same in any particular case, and just that constant gives us different vertical shifts in this case. Okay, that's it for this problem. Thanks, and I hope that helps.